We are discussing the chapter number 5, that is data handling. So if we have information like runs which is made by batsmen in last 10 test matches, you can say number of wickets taken by bowler in last 10 ODIs, marks stored by students of your class or any class in some subject, number of storybooks read by each of your friends. So this information which are collected here, these are called data. And with respect to certain situation, requirement or scenario, this data is collected. For example, the teacher may be interested in knowing the average height of the students in her class. For that, she'll ask all of you or someone of you, any one of you, to write collect the data of all the students, the heights. Now, so this is very important, collecting the data, but more important is to organize this data in certain systematic manner and then to get an idea, analysis, interpretation from them. And the good part is the graphical representation of that data will give you more clear picture, because one picture is equivalent to 1000 words, right? This is a pictograph. A pictograph represents the data using symbols. For example, if we just represent one car, you can say a picture or an image with 100 cars, you can just say in July we have 1, 2 and half. That is, this is 100, this is 100, this is 250. Right? So 250 cars were there. August, 100, 100, 100, 300 here, 100, 100, 100, 100, that is 400. So how many cars were produced in the month of July? July 250. In which month was maximum number of cars produced? So we have September, 400 cars were produced. Then we have bar graph. See, when you eat chocolate or a bar chocolate, you might be remembering it. So it's kind of a bar. Similarly, we represent here in the bar graph the information using these bars, these towers you can say. And these are of uniform width. And the heights are actually proportional or varying with respect to certain values. For example, the bar heights, as we said, gives the quantity of each category, and bars, as we said, are equal width with equal gaps in between. So if these are the number of students in certain class and these are the year, so see 100 students were there in 2003, 2004. You can say there is a gradual increase in the number of students, and 2002 to 2007-8 there are around 350 students. So the data which you can decipher or you can easily find out the information, or you can say interpretation can be done, is what is the information given by the graph? It is the number of students here and the year. So this is year, this is number of students. And in which year the increase is maximum, in which year the number of students are maximum, and you have to say true or false. So the number of students during 2005-06 is twice as of 2003-04. So let us see. 3-4 there were 100, and here we have 200. So it's good. It's 100 here and it's 200 here, right? So one thing, and there are other questions also that in which it is maximum. So 350. Then we have one more query, we can answer it, that increase in the student number of students is maximum. So let us see. Here we have 200, so 100. So here the increment is of 100. Here the increment is of 200 and 250, that is 50. 200 minus 200, 250 minus 200. This is 300 minus 250, that is 50 again. Here we have 300 and 350, so it is 50 again. So the immense increase is here from 2003-04 to 2004-05, and it is double. So then we have double bar graph. Now you want to compare two data simultaneously. So this is double bar graph. We also have multiple bar graph. If you want to compare 3, 4, this is also possible, but here we'll learn about two sets of data which are compared, which we want to compare simultaneously. And how to compare the data? See, this is the marks obtained by students in 2005, 6 and 6, 7. So this is the mathematics marks. See, in mathematics 2000, this is showing 2005, 6. So 5, 6 and 6, 7. So there is an increase in the marks of, or there is the marks in 6, 7 is higher than marks in 5, 6. And how much higher? This is 30, this is 60. So the difference is 30. Here there is an increment in the marks, but it's less. Again, there is an increase in marks, but here there is a decrease in the marks. That means there is, if you see in English, it's if you just equate it, let me say it's say 50. This is around 45, I guess. Yeah, 45. So 50 and 45. So 5 marks in 5, 6. The marks in English have dropped to 6, 7 by 5. And in Hindi, the marks remain same. So you can easily answer these questions. What is the information given by the double graph? These are the marks comparison. These are the marks comparison of 2 years. In which subject student has performance improved the most? The first one. Deteriorated. That is this one. See, it has deteriorated here in English and it is increased in maths. And then in which subject is the performance at par? That is this one, the last one, Hindi. It was earlier 5, 6, same as the latter one, that is 6, 7. Organizing data. So the data which we generally collect, it's called as a raw data, right? Now raw data has to be, you can get an information from raw data. I will not say you will not get, but if it is not organized, it will be very difficult to get any kind of meaningful inferences or some interpretation or some kind of analysis if we have a data which is in raw form. For example, a group of students, if they were asked for their favorite subject, the result is like this. Somebody say art, math, like this. So which is the most liked subject and which one is the least liked? So you have to count art 1, art 2, like this, okay? And again for English you have to count. So this is a raw data. And now we will try to make this raw data, convenient for us to interpret. Means we will organize this data, arrange them. So now we'll compute like this. Art, this is 1, 2, 3, 4, and when we reach 5th, we just use this, you can say bar or you can pipes. And when we compute 1, 2, 3, 4, and when we come to 5, we cross them so that this is equivalent to 5. So this is 5, this is 2, so there are 7. We'll just go back to our raw data and try to see how many of English is English. How many people have said, or students have said English. So this is 1, this is 1, this is 2, this is 3, and this is 4. So 1, 2, 3, 4. Like this we'll put the bar, like this. Okay, 4. So these are the number of students who have arts, who have who presented or who said that their favorite subject is art. 5, 7, 5, 6 and 4. English 4. So the number of tallies before each subjects, as you just saw, is the number of students. We represented it by bar, or you can say the vertical bars, and finally we computed it. And this is also known as the frequency. The 7, the 5, the 4, the 6, they are frequency. So frequency is the number of times that a particular entity will or entry is going to occur or is present there. In this, the frequency of mathematics is this much, 5. So frequency is 5. This is 5. So the table made here is known as frequency distribution table because it provides us the number of times an entry occurs. I hope you got the idea. Grouping data. Now, if the data is less, for example, there are less students, say 10 students, they are being asked about their heights or their favorite subject, it's good, right? Say if 7 students like art, mathematics are like by 5, it's good. But, and we can just represent it using pictograph and bar graph. But what happens when we deal with a data which is larger than that? 10, more than 10, more than 20, like this. Because human mind has certain limitations, human eyes have also certain limitation. So if we see this kind of data, this becomes a little bit clumsy, and we need some other form or some other way to group this data. So this is the data of mathematics mark of 60 students. These are 60 students of certain class. So what we will do here is, we'll group them. We'll group them like this. First we'll make a group, then we do the telemarking, and then the frequency. We'll just add these number of vertical bars and put it here. So basically these two columns are same. So what we'll do, we will try to group them 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. And here, see, since 0 is included here, so 10 will not include here. We'll include 10 here. So 10 is not included. 0 to 10 means 0 to 9 basically. And then here 10 to 19, 20 to 29, like this will go. But it depends on you also. You can just include 10 also here. That is not a big issue, but we'll try to stick to our provision that we'll go from 0 to 9, 10 will take here. So this will start from 10 to 9, go up to 19. This is 0 to 9. Now, this grouping, essentially what we have done, for 60 students, we have tried to squeeze the data in 5 or 6 groups. So essentially we are seeing 1, 2, 3, 4, 5, 6 groups. Now 6 groups are now our eyes, our mind, our brain. Now we are able to understand better. 60 data presented at once, 600 data presented at once will be very difficult to understand. So now let us go and check for 0 to 10, and likewise you will also do for others. So 0 to 10, let us go. 0 to 10, which is 0 to 10? I am not including 10 here. 0 to 9 will go. So 1, this one, 5, and we have 7, right? 5 and 7. So we have 2 entries. So we'll put 2 vertical bars here, and there is nothing else. So this is 2, and we write just 2. And likewise for every other. Please remember that 1, 2, 3, 4. The fifth one has to be like this, cross. So this is equivalent to 5. And then for sixth one, we'll again do this thing, right? So this data which we grouped is called as grouped frequency distribution, right? So now here you can draw very good inferences, like most of the students have scored between 20 to 40. See, most of the students have secured from 20 to 30, sorry, and then from 50 to 60 only one student has secured this marks between 50 to 60. And there are various groups we have made. We call them as class interval. Now, as I just said, 0 to 10 and 10 to 20, in both of these 10 is occurring. So we cannot take 10 in this group also, this group also. So there is a kind of conflict, and we'll solve this, or we'll try to avoid this conflict by our convention which we have used, that 10 belongs to the next class. So 0 to 10, 10 will not belong, but 10 to 20, 10 will belong. So 0 to 9, 10 to 19, like this, right? So this lower is called the lower class limit. The higher number is called the upper class limit. And the difference in all the cases is same. See, 10 minus 0 is 10, 20 minus 10 is 10. So every time the difference are same. And this difference is nothing but width or size of the class interval. Bars with a difference. We have this one as the grouped frequency distribution. Say we have certain marks, right? We have marks which are obtained by, say, 62 students in mathematics class. So we have 0 to 10. So the number of marks or number of people, number of students who have received or who have secured marks between 0 to 9, they are 2, between 30 to 40, 90 like this. Now this can be showed in a graph. This can be displayed graphically in the graph. How? See, from 0 to 10, 10 to 20, these are the class intervals, 20 to 30. And here we have taken marks of the students. Here we have taken on the x-axis, we have taken marks of the students. Y-axis, we have taken this is y. Y-axis, we have taken number of students. Now we can easily mark from 0 to 10 2. Why? Because 0 to 10 we have 2. 10 to 20 we have 10. So we will mark 10 and we'll make a bar out of it. See how simple now it is to understand this data using a graph. So the heights of the bar, they are simply the frequency or number of students of the class interval. And see, there is no gap between these. There is no gap, right? 0 to 10. Because why there is no gap? Because 0 to 10, and then we start again from 10 to 20. So there is no gap. So this graphical representation of data in this kind of manner is called the histogram. But this graph is something different. Here what the minor difference is, we are not starting from 0 to previously in this data or in this frequency distribution graph, you can say table, and this is the graph and this is the table. In both of them we started with 0, but certain cases like this case, in this we have a representation, the range we have divided from 20 to 25 because the age of 25 teachers of a school, the lowest age is 20. So we have no entry between 0 to 20 or say 0 to 19, no entry. So we will show it by a jagged line. This is called a jagged line like this. And this is called a broken line that we have used along the horizontal line just to indicate that we are not showing the number between 0 to 20, rather we are starting from 20. But the rest thing remains same. These are the bars of equal width with no gaps in between because we have the class intervals which are overlapping, and the heights of the bar give the number of data items of a particular group and is the frequency. So this is the age in the years, this is the number of teachers. There is a little difference between these two graphs, which is it is starting from 0, this is not starting from 0, this is starting from 20. So we have a jagged line or a broken line. So from this graph we can easily answer how many teachers are of age 45 years or more but less than 50 years. So 40 and more, 40 years or more and less than 50. Let us go back. 45 and less than 50. So this is 5. The next one is how many teachers are of age less than 35 years? 35 years. This is 35 years. We have to take from this point to this point. So 6 plus 5 plus 4, that will be 15. This is how we answer, and this is the bar with a difference. Circle graph or a pie chart. You know, circle, the circle has pi in it. That is why we call it as a pie chart, and circle is all about this pi because the area is pi r squared, the circumference is 2 pi r. So we can represent the data in circular form also because it's in the circular form it becomes more easier to interpret the data. For example, here the time spent by a child during a day, see 8 hours in sleeping, 6 hours in schooling and 4 hours homework, 3 hours of playing like this. An age group of people in a town, say 0 to 15 years, they are getting around, they are 30,000 or spending 30,000, 15 to 60, 50,000, or you can say they are the number of people, you can say. There are multiple data which we can represent. I'm just giving you few ideas. This can be 50,000 can be the numbers, this can be the amount they have, all these, you know. So these are called circle graph. Circle graph. So circle graph is basically a relationship between the part and the whole. So we divide the circle into different sectors. This is called a sector. The size of each sector is actually proportional to the information or the quantity it has. For example, in this graph, we'll just go the proportion of sector for hours spent in sleeping. See, this is sleeping, so this is 8 hours. This is 8 hours sleeping. And how about full of them? This is 8 plus these are total number of hours are 24 hours. So 8 by 24. So what you get? 8 by 24. So we have 1/3 part of the circle, that is 1/3 of a sector is being given to the sleeping part. So 1/3 part of the circle, this sector has been provided. Similarly, the hours spent, if you want to compute hours spent in school, so this is 4 hours, total is 24 hours, 6 are 24, so 1 by 6, this is 1 by 6, and 1 by 6, 1 by 4 can be the hours spent in school, some is hours spent in, this is homework, so this is homework for 1 by 6, school 6 by 24, 6 to the 18, 6 4 to 24, so this is 1 by 4 as suggested here, this is 1 by 4, so we give 1 by 4 part, that is 90-degree part to the circle. So how the size of the other sectors can be found out? You can just check it out. The circle graph is also known as pie chart. This is the pie chart. How to draw a pie chart? How to draw a pie chart? See, we have an example. The favorite color of, say, ice cream for students of school is given in these percentages. So we have this chocolate as 50%, vanilla 25%, 25%. So the best idea is, this is 50%, 50 by 100, you just multiply it by 360, because a point has an angle 360 degree. This is whole 360 degree. So what part do you want? 50 by 100 into 360 degree. This is what is being done. So let us learn it formally. The total angle at the center of the circle is 360 degree. The central angle of the sector will be a fraction of 360 degree, which will be a part of 360 degree. So what make a table to find, or we will try to make a table to find the central angle of the sectors like this. These are chocolate, 50% like 50% of the student like this flavor. So this is 50 by 100, 50 by 100 is half, and this half is simply half into 360. We want to, because half is showing that half of the circle has to be given to chocolate. So half into 360 degree has to be given to chocolate. Half into 360 degree is 180 degree. Similarly, 25%, so 25 into 25 by 100, that is 1 by 4 into 360 is 90 degree for vanilla and other flavors. So now, how to make this? We have to draw a circle with any convenient radius which fits in our text, the notebook which you are using. Just mark this center as O, the radius as A. So this OA is your radius. Now we have to draw 180 degree for chocolate. Just try to make a you can say a diameter, or you can just start from some radius and take 180 degree. This hole has to be chocolate. You can shade it also. The remaining sector again from this point to this point make 90 degree. Other will be also 90 degree, because the total sum of the angle should be 360 degree. So this is how we draw it. This is a pie chart. This gives the expenditure in percentage of certain items and also the saving of a family during a month. So this graph shows this data, and the question being asked is on which item the expenditure was maximum. See, you can just take in view, or the concerning the percentages. So in which item the expenditure was maximum? See, which is the maximum? 25% on food. So expenditure is maximum on food. Expenditure on which item is equal to the total savings of the family? So savings is what? Savings is 15%, and education is 15%. So education and expenditure on these two, they are 15%. Then if the monthly savings of the family is 3,000, what is the monthly expenditure on clothes? So 3,000, and since we want to find out the expenditure on clothes. What is the expenditure on clothes? This is 10%. So 10% of 3,000. 10% of 3,000. That is, you just have to say 10% of 3,000. That is 10 by 100 into 3,000 you want to do. Sorry, 10% of some amount you have to do. But before that, it is being given that the monthly saving of family is 3,000. So actually 15% is representing the 3000 which is given in the question. So 15%, the monthly saving is 15%. So 15% represent 3000. So how much this 10% is going to represent? This is 3000 by 15 into 10. Here's 1000 into 15 by 10 is 2000. This is how we get the monthly expenditure on clothes. On a particular day, the sale of different items of a banker shop is given like this. We have to draw a pie chart. So the total is 720. See, 320 plus 80 plus 160 by plus 120 plus 40 is 720. Now how to get the, we basically we are interested in the angles. When we are drawing a pie chart, we are drawing a circle. So we are basically interested in angle, what angle we have to give to each of them. So it's quite easy. 320 by 720 into 100 into 360, not 100. 80 by 720 into 360 is 160 by 720, because 160 part of 720 is the part being taken by, say, cake and pastries, and in order to get the angle you just have to multiply by 360. So what we do here is we will make a table, we'll give an item here, sales here, in fraction, that is 320 by 720, 120 by 720, 160 by 720, like this, and these are the fractions. These are the fractions, and we just have to multiply this fraction by 360 degree to get the angles, right? So we can make the pie chart, because now we know the angle. This is 160, this is 60, like this. All these angles are there. We can just, either you can shade in different colors, shade with certain bars, and you can write here ordinary bread 160 degree, fruit bread 640 degree, like this. Chance and probability. If it is a raining season, you will take a raincoat. But if it is, you are not confident, there is a chance of getting rain, that you may or may not take the raincoat, right? So there are chance one day you forgot to take the raincoat and it may rain heavily. It may happen that student prepare, he might have 5 chapters in the book and he prepares, say, 3 or 4 of them. But it may happen that the teacher take the question or put the question from the chapter the student have not prepared, or she has left unprepared. So everyone knows that particular train runs in time, but you late reach. That may happen. So these are all the examples of chance. You may get it, you may not get it. You cannot say beforehand that it is going to happen or not. Even if you prepare 5 of 5, then it is possibility that the teacher may give you a question which you may not be able to solve. This may be possibility. You are on the time, but train may not come. So these are all the chances. But we are discussing here that there are certain experiments whose results have an equal chance of occurring. How to get a result? A cricket match starts. Now the two team captain go out and they decide which on a toss of coin, that who is going to bat first or who is going to ball first, right? And the tossing of a coin, it may give you head or it may give you tail. Now the captain of one team, he asks you that, okay, what do you think, what may come? Can you tell what is going to come? Can a head can come, a tail can come? So both have equal possibility or equal chance of coming. Head can also come, tail can also come. So this is called a random experiment. Head and tail are the outcomes of this experiment. So tossing a coin is the random experiment, because head and tail can come, any one of them can come, and this is the outcome. Head and tail is the outcome of the experiment. Equally likely outcomes, as we said, when we toss a coin, head can also come and tail can also come. No one in this whole world can say perfectly that now head will come. He might be just guessing, and his guess is always half time, that is 50% correct, because 50% head and tail, because there are two options. One is going to come, so 1 by 2. One option can come, there are 2 options, 1 by 2 is 0.5. 0.5, that means 50% probability or chance or likelihood of coming of head and tail may maybe the outcome. So let us go to the result in which we increase the tosses. See, we have number of tosses as 50, number of heads are 27, number of tails 50 minus 27, that is 23. We increase the number, we go to 80, now the number of heads are 38 and tails are 42. Then we go to 100, you see the result is coming nearer to 50, right? Both of these. So we observe that when we increase our observation number of experiments, the value comes nearer to what we would have expected, that is half or 50%. So we may say that different outcomes of the experiment are equally likely. That means each of the outcomes have the same chance of occurring, that is a coin. A coin may fall like this, but this we don't consider. This two scenario we don't consider when we throw a die. And dice or die is simply a small cube with numbers on it. So there are 6 faces, so 1 to 6 numbers are being printed. Linking chances with probability, just consider the example of tossing a coin. The outcome can be head and tail. So there are 2 possibilities, or 1 is the possibility of head. So half is the probability of head, half is the probability of tail. So the probability of getting head is half. And what is the probability of getting a tail? Again, half. We'll take an example, or say throwing a die, 1, 2, 3, 4, 5, 6. We have different faces on the say a cube. Cube has 1 to 6 faces, and 1 to 6 dotted are printed there. So if you throw it at once, what are the outcomes? 1 to 6, all can come. So there are in total 6 outcomes possible, and once if you throw it, only one face can come. You can read the top face. That is, it may come 1, 2, 3, 4. So every time one of these number can come. So the total number, this is the number of outcomes, say giving you interested in 2, the number of outcomes giving 2, and these are the number of equally likely outcomes, and this is the probability of getting a 2 when you throw a dice. What is the probability of getting 5? Again 1 by 6, right? Outcomes as events. Each outcome of an experiment or a collection of outcomes, it forms an event. If you toss a coin, head may come, it is an event. Tail may come, it is an event. When you throw a die, 1 to 6 can come, so this is an event. But getting an even number is also is an event. Getting an odd number is also an event. So even number 2, 4, 6, how many are these? 2, 4, 6, so these are in 3, total 3, and total number of outcomes are 6. So getting even number is 3 by 6, because even means 2, 4, 6. So we are taking out of 6, 3 as the event. So the event is total number of outcomes that makes the event, which is our 2, 4 and 6, and total number of outcomes of the experiment is 6. A bag has 4 red balls and 2 yellow balls. A bag, 4 red balls and 2 yellow balls. The balls are identical in all respect other than the color. So ball is drawn from the bag without looking into the bag. What is the probability of getting a red ball? So in all, how many balls are there? 4 plus 2, 6. And red balls are 4. So 4 by 6 is the probability. How a ball is drawn? Is it more or less than getting a yellow ball? Yellow ball is what? Two yellow balls can come, right? And there are in all two yellow balls are there. You can pick any of these 2, but the total are 6, so 2 by 6. So this is basically 2 by 3. This is 1 by 3. Which is greater? This is the greater one. So the probability of getting a red ball is more than the getting a yellow ball. Chances and probability related to real life. Everything in our life is a chance. You are giving an exam, you may pass, you may not pass. You are going, say, I'm just taking some examples like raincoat. You are taking a raincoat, it may not rain, but it may rain also. So what could you say about chance in terms of probability, right? Say 10 days during a rainy season, the probability that it rains is 1 by 10. So probability it does not rain is simply 1 minus 1 by 10. The probability, the total probability of event is always, or you can say an experiment is always 1. So event is 1 by 10. The possibility of happening an event is 1 by 10, not happening is simply 1 minus of that event. 1 minus 1 by 10, that is 9 by 10. So to use the probability in various real life, just take an example to find characteristic of large group by using a small part of a group. For example, the exit poll. So you take, after elections, you just ask certain people whom did you vote, and you take a sample size, and then on the basis of that you can declare, or you can say that who is going to win. The meteorological department predicts whether by observing trends from the data of previous years it is going to rain, or you may have thunderstorm like this. So what we have discussed, data mostly available to us is an unorganized data which is called as a raw data. So we need to find out the if we want to analyze or get some meaningful inferences from this data, we need to organize this data systematically. The frequency gives the number of times a particular entry is there or entry is occurring. The raw data can be grouped and presented in various forms. One of them is grouped frequency distribution. The group data can be represented using a histogram, which is nothing but the frequency distribution. Histogram is a type of bar diagram where we have class intervals on horizontal axis. Height of the bar shows the frequency of class interval, and there is no gap between the bars, as there is no gap between the class intervals. Then data can also be represented using the circle graph or a pie chart. The circle graph is showing the relationship between a whole and a part, and there are various experiments whose outcomes have equal chance of occurring, like the throwing of a die or tossing a coin. A random experiment is one whose outcomes cannot be predicted exactly in advance. The outcomes of experiments are equally likely if each has the same chance of occurring. Any probability of any event is number of outcomes that make an event and the total number of outcomes of the experiment, right? One or more outcomes of the experiment make an event, and chances and probability are related to real life. So thank you so much. This is all about this chapter. Take care of yourself.